Good morning, BYW students. Today we're going to be learning about how to classify numbers. Before we go into classifying numbers, it's important for us to just give you the heads up. There's no real computations going on. There's no math going on. We're just classifying. So it's basically just making sure that we know how to classify a number. So as you can see, there's a bunch of terms on your paper. We got the real numbers, we got the rational numbers, we got the irrational, we got the natural, we got the whole, and then we got the integers. So here's how it works. We have these numbers and we need to classify them. And the reason why we classify them is so we can make sure that we have a nice and orderly system. It also makes sense because once we classify things, we can sort of group things together just to make them work in our favor. So the first number we're going to look at is the real number. So the real number is any number that is positive or negative, large or small, just not imaginary. So some examples of real numbers are the number 1, the number 2, the number pi, 2/3, basically any number you can think of. I can even say -9/8. I can say any number that you can think of, and that's a real number. It can't be imaginary. So the reason why I'm saying it's not imaginary is because in a few years, when you take Algebra 2, you're going to learn about these things called imaginary numbers. So your imaginary friends will exist in 2 years. They just won't exist here. They'll exist 2 doors down in Miss Daniel's room. Our next number is the rational number. The rational numbers are very special to me, and here's why. The rational numbers contain a bunch of different numbers. They are the natural numbers, the whole numbers, the integers, the terminating decimals, the repeating decimals, and the fractions. So basically, if you look at rational, it has the word ratio. It has the word ratio. So as long as you can write things as a ratio, it's a rational number. So the number 1/2 is a rational number. The number 2/3 is a rational number because I can write it as a ratio of 2 integers, which is just a fancy way of saying I can write it as a fraction. The number 5 is a rational number. And the reason why 5 is a rational number is because guess what? It's a nice number. So as long as you can say nice things about your number, it's a rational number. Now what we're going to do is we're going to look at the irrational numbers. The irrational numbers are not as special to me because guess what? They're a little annoying. Guess what? They're irrational. It's a real number that can't be made by dividing 2 integers. These numbers go on forever and ever and ever without repeating. So our real world example of an irrational number is going to be the square root of 2. Because I can type that into my calculator and never get a repeating decimal, or pi. So what I'm saying is that pi is not only real, it is also irrational. So what we're going to be doing today is we're going to be looking at how these numbers are multiple different types. So for instance, I'm Mr. O'Sullivan, I'm a teacher, I teach math, I also teach advisory. Those are the ways you can classify me. Our next numbers are the natural numbers, and it's natural to start at the number 1. So our natural numbers are simply the numbers that we can count. So the numbers that we can count are 1, 2, 3, 4, 5, and so forth. It goes on forever and ever and ever. If you want 100, yeah, that's a natural number. If you want $1,000, guess what? That's a natural number. But if you want $1,000.38, you're wrong. That's not a natural number. That's a rational number. And it's also real. Our next number is the whole number. The whole numbers are also a lot of fun because guess what? They're the numbers we can count. And it's also the number 0. So I'm starting at 0. And I'm doing 1, 2, 3, and so forth. All of those numbers. So basically, it starts at the number 0, and it keeps on going. Our last number that we're going to look at today are the integers, and the integers are very, very special. They're Miss Townsend and Miss Jimenez's favorite numbers. They are positive and negative numbers. The only issue, they just can't be a decimal. So I'm going to just write down a few examples real fast. Our examples of integers are -2, -1, 0, 1, 2, and so forth. And it goes on forever and ever and ever in both directions. At the bottom of your page, you will see this nice little flow chart. It's basically saying that we have the real numbers. And when we have the real numbers, we can break apart into the rationals, and we can break apart into the irrationals. If it's irrational, it cannot be an integer, a whole number, or a natural/counting number. So what we're going to be doing today is, if it's a natural number, it has to be a whole number, it has to be an integer, and it has to be rational, and it then becomes real. So that's what we're going to be looking at today. We want to figure out how we can classify these numbers to make sense. So we're going to identify all of our classifications. So you should have written down next to you the words real, rational, irrational, integer, whole, natural, and that stuff. So the first number we have is pi. I said it before, pi is real because everything is real in this course. It's real. But the thing is, pi never repeats. So when we talk about the number pi, it is irrational. So pi is real and it's irrational. Now, if I look at the -2, the first thing I said was all these numbers are real. So I immediately write down real. And I ask myself, is it rational? Which means, can I make it a fraction? Yeah, it's rational. I can do -2/1. I ask myself, is it irrational? Nope, it's not irrational. I ask myself, is it a natural number? Well, the natural numbers are 1, 2, 3, no negative, so it can't be natural. I ask myself, is it whole? Well, whole numbers are 0, 1, 2, 3, no, it's not whole. And then I ask myself, is it an integer? Our integers are negative numbers and positive numbers, and guess what? -2 is a negative number. So yes, this is an integer. This is an integer. Now let's go on to the next example of 2/3. We guessed it, it's a real number because all of these numbers today are real numbers. So I have a real number. I need to ask myself, is it rational? Well, it's a fraction and it's a nice fraction, so it is rational. Because it's a ratio of two integers. It's a ratio of 2 to 3. And when we look at our flowchart, we then go into integers, whole numbers, and counting numbers. Those can't be fractions, those can't be decimals, so the only thing I can say about 2/3 is that it is real and it is rational. Let's go on to our next example. We've got 0.234. Well, I can read this 234 as 234 or 234 tenths, hundredths, thousandths. This is 234 over 1,000. So guess what? We just turned this decimal into a fraction or a ratio of two integers of 234 to 1,000. So not only is this fraction real, it is rational. Because it's a ratio of two integers. Now we're going to go on to our next example of 0.234234. Well, we know it's real, but it's a little special. It is also rational. It's rational because it's repeating. 234, 234, 234. So it is a rational number as well. Perfect, and that's it. It is not an integer, it is not an irrational number, and it is not a whole number. Let's go on to our final example from this section. I have 0.234, 23545. Well, we know it's real because everything today is real. But it is not rational. It is irrational because none of my numbers are repeating. So it's not repeating, so it's irrational. Now let's go on to our next set of problems. Below, you might see some things you haven't seen before, specifically that radical symbol. So whenever you see a fancy division sign, that's a radical. We will learn more about this as we move throughout the year, specifically when we get to quadratics and how to solve them. To type this on your calculator, you follow these commands. I put in the symbols, the second and x squared key, and then you should get that on the right. So when I type in radical 21 on my calculator, or if you want to go to Desmos, you could do SQRT and then put the number under the radical. When I type in radical 21, I get 4.5825, 5825, 75695, and I'm looking at this. There's nothing repeating, so I know it's irrational, but we also said that it is everything today is real, so it is real and irrational. Our next example is the square root of 25. The square root of 25, I type it into my calculator and I get the number 5. So we know it's real. We know it's rational because I can do 5 over 1 and it's a nice number. We know it's natural because I can count it. And we know it's a whole number because guess what? Natural numbers are whole numbers. And last but not least, we know it's an integer because it's a positive, nice number. So 5 is a lot, or the square root of 25 is a lot going on. Last number is 0. We know 0 is real. We know 0 is rational because 0 over 1 is 0. We know it's an integer because, remember, it's the negatives and the positives. And last but not least, we know it is a whole number. It is not a natural number because 0 is not included in the natural numbers. So here's your next step. You need to complete the independent practice checklist, which is basically a table where you complete to figure out which numbers are rational, irrational, and so forth. If you have any questions, email myself, Miss Townsend, or Miss Jimenez. Have a great, great day.